Hey everyone, Mr. Hauk here. In today's video, we're going to look at simplifying trigonometric expressions. Let's go and get started. So we've spent the last several lessons building kind of a trigonometry toolkit. We've got some reciprocal trig identities, we have some quotient trig identities, some indifference formulas, double angle formulas, and we even just proved the Pythagorean identities as well. So what we're going to start doing is we're going to start using all these trigonometry tools to start simplifying trig expressions and eventually start verifying trig expressions. And we're going to start kind of slow. So in today's lesson, we're going to only be using algebra along with the reciprocal trig identities, these 6 right here, and the quotient trig identities, these 2 right here. And let's just review them real quick. We know that sine and cosecant are reciprocals, so sine of theta is 1 over cosecant theta, and cosecant theta is equal to 1 over sine of theta. We also know that cosine and secant are reciprocals of each other. So cosine of theta is equal to 1 over secant theta is equal to 1 over cosine theta. And we also know that tangent and cotangent are reciprocals as well, meaning that tangent equals 1 over cotangent and cotangent equals 1 over tangent. We also know that the tangent of an angle is equal to the sine of the angle divided by the cosine of the angle, and we know that the cotangent of the angle is the cosine of the angle divided by the sine of the angle. And one of the tools that we're going to use quite a bit when we start simplifying these expressions is decomposition. We're going to be decomposing a lot of these trig expressions into expressions of sines and cosines. So what we want to do for each one of these examples, we want to simplify as much as possible. And each one of these 5 examples specifically, we're going to be able to simplify it down to either a single trig function or a numerical answer or a constant. Okay, so let's start here. We want to simplify this expression, cosine of theta times cosecant of theta divided by cotangent of theta. And again, we want to simplify it down to either one trig function or a constant. Okay, so here's what we're starting with. And one thing that I want to go ahead and do is I want to go ahead and decompose everything that we can into sines and cosines. So that's what we did first. We decomposed everything into sines and cosines. Well, cosine is already cosine. Cosecant is 1 over sine. So notice that I'm replacing this cosecant of theta with 1 over sine of theta. And cotangent of theta is cosine theta over sine theta. That's our quotient trig identity right there. So I'm decomposing everything into sines and cosines. Once I've done that, then notice that, up here in the numerator, this is like a cosine over 1, by the way. So cosine theta times 1 over sine theta gives me cosine theta over sine theta. In the denominator, we have cosine theta over sine theta. Well, notice this is the same thing in the numerator as we have in the denominator. So it's cosine theta sine theta divided by itself, cosine theta sine theta, which is just 1. Okay, so we simplified this expression as far down as we could, and we got the constant 1. So that's kind of the goal here, simplify as much as we can. All right, our second example, we want to simplify tangent squared of theta times cosecant squared of theta. Again, our goal is to simplify it down to either one trig function or a constant. So let's approach it very much the same way. I think we should decompose tangent squared of theta and cosecant squared of theta into sines and cosines. And if I do that, I kind of jumped ahead a little bit there. But if I do that, let's think about this real quick. Tangent squared, well, we know tangent is sine of theta over cosine of theta. So tangent squared is going to be sine squared over cosine squared. And cosecant, well, we know cosecant's the reciprocal of sine, so cosecant squared will be 1 over sine squared, which is what happened in this step. We got the tangent squared of theta turning into sine squared of theta over cosine squared of theta, and we have cosecant squared of theta turning into 1 over sine squared of theta. Notice these are multiplying. We have a sine squared theta in the numerator and in the denominator, so they will cancel each other out. All we'll have left is 1 over cosine squared of theta. But 1 over, if we think about 1 over cosine itself, well, 1 over cosine is secant. So 1 over cosine squared is going to be secant squared of theta, which is our simplest form. Again, notice this is a single trig function, a single trig value. All right, So hopefully we're kind of understanding the process here. Let's try some that might be a little more algebraically involved now. Some of them might. This one actually, as crazy as this one looks, I remember this one being pretty actually simple. All right, so we want to simplify sine of theta times tangent of theta times cotangent of theta times cosecant of theta plus tangent of theta over secant of theta times cosecant theta. Well, as crazy as it looks, let's take the same approach. Let's decompose everything into sines and cosines, meaning that this tangent right here, tangent of theta, will turn into sine theta over cosine theta. Cotangent of theta will turn into cosine theta over sine theta. Cosecant of theta will turn into 1 over sine of theta. Tangent of theta will turn into sine theta over cosine theta. Secant of theta will turn into 1 over cosine theta. And cosecant theta will turn into 1 over sine theta. All right, so a bunch of stuff happening here. And here's everything that I just said. So there's, the sine of theta is going to stay the same. There's tangent of theta. There's cotangent of theta. There's cosecant of theta. There's the tangent of theta on the top. Here's the secant of theta. And here's the cosecant of theta. Okay? But now watch, a bunch of stuff is going to cancel, and we can kind of see it already. This sine will cancel with this sine. This cosine will cancel with this cosine. This sine of theta and denominator will cancel with this. Imagine this is like a sine over 1. So this whole thing is actually going to turn into a 1, ironically enough. And then same deal over here. This cosine theta and this cosine theta will cancel because they're both in denominator. And then this sine of theta will cancel with this sine of theta in denominator. This whole thing is also going to turn into a 1. Pretty crazy. So a bunch of stuff cancels. We get 1 plus 1, which is just 2. It's a pretty cool problem. Looks complicated at first glance. Answer turns out to be 2. All right, let's try this one here. So let's simplify the sine of negative theta times cosine theta divided by tangent theta. And this is, notice we're getting a negative, sine of a negative angle in here. So we're going to use our even and odd identities for this one. So first things first, there's the problem. That's what we're starting with. Couple things I'm going to do in one step here. I'm going to use the even and odd identities. We know the sine of negative theta is really negative sine of theta. And then I'm also going to decompose this tangent of theta into sine theta over cosine theta. Okay? And you're noticing in a lot of these problems, the very first step is to decompose everything that you can into sines and cosines. It's a very useful strategy. So, that's what I do first. Sine of negative theta is going to equal negative sine of theta, and tangent of theta is sine theta over cosine theta. So here's the replacements. Next, I'm going to go ahead and do our little keep change flip that we do when we're dividing fraction within a fraction. So we're going to keep the numerator the same, negative sine theta times cosine theta. We're going to change the division to multiplication, and we're going to flip the denominator. So instead of sine theta over cosine theta, we'll have cosine theta over sine theta. And then watch stuff cancel. So here's cosine theta, or sorry, here's sine theta. Again, pretend this is like a sine theta over 1. This sine theta will cancel with this sine theta. The negative will stay though, so don't forget that negative out there. And then cosine theta times cosine theta will be cosine squared theta. So we'll have negative cosine theta times cosine theta, or negative cosine squared theta. And that's as simplified as we can get. All right. So for our last one, this is going to be our most challenging because of some of the algebraic skills involved. Now, I would encourage you to pause the video at this point and try this one on your own, and unpause it here once you've tried it. But let's go through the process here and see how this is going to play out. So we're starting with sine of theta plus tangent theta over 1 plus secant theta. And we want to, again, simplify this down to either one trig function or a constant. And I'm going to take a very similar approach as I've done with the other examples. I'm going to decompose everything that I can into sines and cosines, meaning this tangent will turn into sine theta over cosine theta, and this secant is going to turn into 1 over cosine theta. So it's going to be my first play. All right, so I've gone ahead and done that. Now when you look at this, some students might get lost as to what you could do next. And one thing that I'm noticing is that we're trying to add a sine theta to a fraction. Same thing here, we're trying to add this 1 to a fraction. And a lot of times when you're trying to add, expressions with fractions, you normally want to get a common denominator. So what I think we should do, or at least the step that I took next, is I went ahead and found, or manipulated this to give everything a common denominator of cosine theta, which means that to get sine theta to have a denominator of cosine theta, we need to multiply it times cosine theta over cosine theta. And then to get this 1, we're going to multiply it by cosine theta over cosine theta as well. Okay, so here's what happens. We can see that the sine theta, when you multiply it by cosine theta over cosine theta, you get this term right here, sine theta cosine theta over cosine theta. We don't need to mess with this term because it already has the common denominator that we wanted. The 1 turns into cosine theta over cosine theta. And we didn't need to mess with this term because it already had the cosine theta that we wanted. And by the way, I just want to be clear. We're allowed to do this. We're allowed to multiply by cosine theta over cosine theta for these terms right here. Because when you think about cosine theta over cosine theta, it's really just a 1. We're really just multiplying by 1, which isn't changing the value of anything in these expressions. Okay? So now it looks a little more complicated. But the nice thing is, they all have these common denominators. And we know that with fractions, when you have common denominators, you can add the numerators together and keep the denominators the same. So we're going to add these numerators and keep the denominators as cosine thetas. And here's the result. So now we have sine theta cosine theta plus sine theta over cosine theta divided by cosine theta plus 1 over cosine theta. So my next goal is, notice we have a fraction and a fraction. They both have denominators of cosine theta, so we know that they're going to cancel out in the next step. So I'm going to go ahead and cancel those out. Right? Cancel the cosine thetas in each denominator. That's going to leave us with sine theta cosine theta plus sine theta over cosine theta plus 1. Now the next step, when I'm looking at this, I notice that in the numerator, both of these terms have a sine theta in common. So I can factor the sine of theta out of the numerator. So notice I take a sine of theta out. I'm going to be left with cosine theta plus 1 in the numerator. And if you don't believe me, redistribute the sine of theta and watch what you get. Sine theta times cosine theta, that's this piece. Sine theta times 1, that's this piece. So factoring the sine of theta out really does work. But now notice you have sine of theta times cosine theta plus 1 over cosine theta plus 1, which means that we can cancel these terms out because it's being multiplied to the sine of theta. So we can cancel this cosine theta plus 1 with this cosine theta plus 1, and the result is simply just sine of theta. So a good bit more work than the other examples, but it shows you, it's a good example to look at because we get common denominators, we get some factoring in here. It's just a good overall example to kind of demonstrate some of these algebra skills that are necessary when simplifying trig expressions. All right. So that's going to be it for today. Again, we started kind of easy with simplifying trig expressions, only using reciprocal identities and quotient identities. And eventually we'll start throwing in the Pythagorean identities and the sum and difference formulas and things of that nature.